Good afternoon, good morning, good evening, depending on when you're watching this. So we're doing something exciting today. We're doing 3 events Venn diagram. So what does that entail? Let me just let you in on the scenario. So the scenario is we have 150 students, well, a survey that was taken of 150 students. And the survey was just trying to find out how many of the students use cell phones, right? Tablets and laptops. So what I did, I called cell phones event A, I called tablets event B, and I called event C the laptops, right? Drew my Venn diagrams, but there's information missing that I still need to fill in, right? Where is the 30 coming from? So the 30 forms part of the data that we're given, the data that is already given. So first of all, we're given this whole probability of A. We're given that it's 125, right? We're also given the probability of B, which is 47, right? And we're also given the probability of C, which is this whole circle, and that is for 58, right? Furthermore, we're given the probability where A intersects B, and that's this area right there, right? And we're told that it's 40. We're told again where A intersects C, so this whole area there, that is given as 50. And lastly, where B intersects C, this whole area there, that's given as 35. So let's get going. Let's calculate what these other areas are. How do we go about doing this? We start from the middle and then work our way out. That's the easiest method to use, right? So let's do some calculations. If I'm trying to find this area, let me call it area A, right? If I'm trying to find that area, I just need to take the total area of where A and B intersect and subtract the 30, and that will give me that area. So let's do it. We already have all the information we need for that. So I'll take the 40 where A and B intersect and subtract it with the A intersecting B intersecting C. So I'll say 40 minus 30 gives me 10, right? I can already put the 10 there. We found that. How do we find this area there? Well, we need where A intersects C, this whole area, subtracted by the 30. So let's find B. I'll call this area B. Where does C intersect A? It's 50 minus 30 gives us 20. So I can already put 20 there. Still with me, right? So how do I find that area then? I'll call that area C. These are just random alphabets I'm assigning to show you where the calculation is happening and where the number is coming from, right? So they don't mean anything, it's just a reference, right? So let's go to C. C, you take where B intersects C, which is 35, subtracted by 30, that just gives us 5. So now we found C, we found B, and we found A, right? Which is those areas there. What else can we find? Remember, we're given the total area of this A, well, the total probability of A. And so if I'm trying to find this big area here, I just need to subtract the total with 10, 30, and 20. So let's apply that. I'll call this area D and reference it down here. So I'll say 125, the probability of A, minus 10, minus 30, and minus 20. What do we get? So just use your calculator there, cuts you some time. We get 65. Wonderful. So we put the 65 up there. Still with me, right? So how do we find that area? Well, we need the probability of B, and we just need to subtract the 10, the 30, and the 5. So I'll call that area A, B, C, D, E. So I say 47 minus 10 minus 30 and then minus 5. What do I get? 47 minus 10 minus 30 minus 5. I get 2. So this area with B is by itself is only 2. And the last one to find C, I'll call this area A, B, C, D, E, F. Obviously, like I was saying, you take the total A, you take the total C minus 20, minus 10, minus 5. And what do we get? Oh, minus 20, minus 30, minus 5. I put 10 there. 58 minus 20 minus 10 minus 5. I get 3. Right? So now we have everything is kind of labeled. Everything but the area where no one, where the students have no phone, no tablet, and no laptop. This area right here. So let's find it. How do you find that area? Well, for one, you could just take that area and subtract all these, right? You'll find it. So let me call this area G. And how we find for G, I hope you can see G down here. We say 150 minus 65, 20, all right. What does that long arithmetic equation give us? It's 150, 65, it just gives us 15. So 15 students don't have a cell phone, don't have a laptop, and don't have a tablet, right? So we're done with these calculations. Can I erase them? I hope you guys took this down. Pause the video, take down all of this, make sure you understand it, right? I want to move on to questions now. I want to erase even the given information. So what do the questions ask us? So I read the questions here. Hopefully I'll send out the picture of the questions to you guys. I'll post it under the comments section as well, so you guys have it and can look at it. The first question asks us to find how many of the teenagers surveyed own only a cell phone. Remember what A is. Let me just erase this. It looks a little bit clustered. All this referencing alphabets. Alright, we can resume now. So the first question wants to find uh, the students that only use phones, right? The students that only use phone is this area where A is by itself. So that we already calculated it, you just need to write it down there. It's just 65, all right? The next question asks, how many teenagers surveyed own cell phones and laptops, but not tablets? So it's looking for A and C, but not B. So it's looking for just the 20. So number 2 will just be 20. Looks like a 26. It's a 20. Right? Number 3. Number 3 asks, how many of the teenagers surveyed own exactly one of the 3 devices? So remember what this is. This is the students that own just the cell phones. This is the students that own just the tablets. This is students that own just the laptops. So if I want to know how many students own exactly one device, then I need to take that 65, add it with the 2, and then add it with the 3. What do I get? 65 plus 5 is just 70. So now we're done on number 4. I hope you're with me so far. So number 4 asks us, how many of the teenagers surveyed owned exactly 2 of the 3 devices? So now they own 2 of the 3 devices. So that's 20. This is people that own a cell phone and a laptop. That's 20. That's people, or that's teenagers that own a cell phone and a tablet. That's students or teenagers that own a laptop and a tablet. So if I'm looking for students that own exactly 2, I need to add these values. So it's 20 plus 10 plus 5. So listen to how the question asks you. If it says exactly, then you need to add those values. Do you get what I mean? And so it's very precise when it says exactly. Later on, we're gonna start doing questions where it says at least, at most. So those ones, it's gonna be a little slightly different. So that's 20 plus 10 plus 5, that's just 35. Number 5. Number 5 asks us, how many of the teenagers own at least one of the 3 devices? Remember what we're doing here, guys. We're trying to find, well, remember what this tells us. This tells us if I'm in this area, that means I own a cell phone, but once I move into that area, then I own a cell phone and a laptop, and a tablet. Do you get what I mean? If I move into that area, I own a cell phone and a laptop. Do you get what I mean? And so if the question asks for at least one of the 3 devices, then it's asking for that, 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 and that, right? Of which you could just find by say the total students minus the ones that don't own anything, right? So how many students own at least one? 150 minus 15 is 135. Right? So, yeah. That's the first question. This is A. Let's look at B. B asks us if one teenager is, so now we're looking for actual probabilities. If one teenager is selected from the group, what is the probability that he or she owns none of the three devices? Well, none of the three devices, that's the 15. So what is the probability that I'll pick someone from that 15? It's that 15 over the total, right? I like putting them in decimals so that I can visualize them. So it's about 10%, right? Number two, it asks if one teenager is selected from the group, what is the probability that he or she owns at least two of the three devices? Two of the three devices starts from there, right? But I'm going to add the 30 as well, because it says at least. At least talks about equal to that value and greater. That's at least. Right? At most speaks about equal to that value but less. Or equal to that value and less. Right? So we're still talking about at least or at 10 plus 20 plus 30 plus 5 divided by the whole sample space. So let's do that. 10 plus 20 plus 30 plus 5. And what do we get? 10. It's about 43%. So the chances that I'll choose someone is about 43%. And then the last question, it asks us, if we were to choose a teenager at random, what is the probability that he or she owns at most two of the three devices? So if it speaks about two of the three devices, then we need to add that and that and that, but now it's at most, so we're adding every other thing that goes after it. So the people that own one device also count, right? So we're gonna do that. So we basically we're adding this long equation: 65 plus 10 plus 20 plus, let me just move there. So 65 plus 10 plus 20 plus 2 plus 5 plus 3 all over 150. And then we get 65 it's about 70%. All right, and that's a wrap, guys. So yeah,